So in the last 3-4 months, together with 3 of my colleagues, we've been working on bringing Plaid back in fashion. And Plaid is an application developed by my colleague, Nick Butcher, who's a design and developer advocate, to showcase material design in Android. So Nick started developing this application somewhere around 2014. And what you see right now is a recording from 2016, when it was pretty much, let's say, Plaid's glory days. So Plaid aggregates data from 3 different sources, from Designer News, Dribble, and Product Hunt. And Nick did an amazing job with implementing all sorts of shared element transitions and animations and everything that's possible to make the user experience with the app more delightful. Some of my favorites, for example, are the vector drawables. So I remember the first time when I got the chance to play around with the app that I pressed that search button like a million times just because I like how that magnifier is transformed into an arrow. It's just so smooth. But from 2016 until 2018, things have changed. Things have changed because some of the APIs that we are integrating with have been deprecated. So, for example, for Dribble, now you can get the information or you can display the data, but, for example, you're no longer able to see the comments. You can see how many people liked it, but we no longer get to see the list of people that actually liked the specific shot. Similarly, you're not able to like the shot. You're not able to follow the user. You're not able to do a lot of the things that make viewing this Dribble shot more delightful. With Designer News, things were actually even worse. So, for example, Designer News for a story allows you to add a comment to the story, but also add a comment to the comment and so on. So it allows these kind of threaded comments. So to improve the usability, Nick created this elevation for an item when you're tapping on it. So like this, it's easier to see to which item you're actually adding a reply. And my all-time favorite feature, I think, in Plaid is the refloat text. Like every time I see it, I still gasp. It's like such a smooth animation, like how the words align. So I don't know, probably now it's going to be too fast, but like the words are not going straight, they're going in an arch, and he makes sure that they don't overlap. He spent a lot of time working on this, and he talked about it in 2016. So this, and also the comments, actually were no longer visible at all, because Designer News deprecated their V1 API. And the third API we were integrating with, Product Hunt, well, this one was working. But this one, unfortunately, was just we are just opening a new Chrome custom tab to see the information. So this means that from that initial delightful Plaid application that we had in 2016, now, feature by feature, since they were deprecated, we were left off with something that was pretty plain, pretty basic. So actually, if you think about it, this is actually quite normal for everyone. For a lot of our applications, our backend that we're integrating with is changing, so we need to adapt. So we didn't want to leave Plaid like this with 1/3 of its functionality, and we wanted to bring Plaid back to life. So together with Nick Butcher, Ben Weiss, and Team Song, we decided to do this. But before we got started, we looked at what we actually want. So we knew that, first of all, we wanted to fix the broken functionality. But because Plaid started being developed in 2014, at that time, we weren't talking about all of these MV star patterns. We weren't talking about reactive. We weren't talking about Kotlin. We weren't talking that much about extensibility and modular architecture. So we decided that that can be a secondary goal for us, to build this modular, extensible architecture based on the Guide to App architecture that we released last year, and of course, with Kotlin. You know how it is, you should measure twice and cut once. So before we started re-architecting everything, we decided on how this should be, how things should look like. So we decided to create a vision of how our code should be. So I was saying that our app integrates with 3 different sources, with Designer News, Dribble, and Product Hunt. So this means that these should be as separate as possible, because they don't interact anyway with each other. So they should be separate modules. So this means that if you want to integrate with another source, we can easily add another module. And even more, in our UI, we have a filter list. So there, only when we want to enable this fourth source, only then the code for it should be downloaded. And only then the information should be requested, and then the data from it should be displayed in our feed. So in order to do this, we decided to use the new app bundle format that we released at I/O this year, together with the dynamic feature modules. So the dynamic feature modules contain contain the code and the assets that you need, and you can decide that you only download that code later on at runtime. So this is done actually via the dynamic delivery feature as part of the app bundles. But you can also separate this code into modules without enabling this dynamic delivery. But it felt like, OK, this is the kind of modularization, the kind of code separation that we want. Because like this, every feature is contained in its own module. But even more, we wanted to separate every module into its own layers. Because like this, we can easily replace, for example, the way we're storing the data in one module with something else without affecting anything else, any other layer above it. So separate, clean, easy to replace, easy to extend. That sounds easy, right? That was our goal. But what did we have? What was the architecture of the app we were starting to work with? This was the best way I could create a diagram of how tight the dependencies of Plaid was. And I wish this was an overstatement. But we knew that we can take this challenge and we can build the architecture that we wanted together with Kotlin. We knew that the Kotlin language features are going to change the way we are architecting our application. So we decided that from the beginning, we're going to start refactoring with Kotlin in mind. So one of the most important decisions that we had to make is decide on how do we handle asynchronous work. So in Plaid initially, everything that was related to the background thread was done via retrofit2 calls. So this means that actually only the network calls were on the background thread. So all the business logic, for example, was still done on the UI thread. So we couldn't do that, of course, so we needed to choose out of different options. So we looked at executors, RxJava, and coroutines. So with executors, well, things work. You can run something on a background thread, but to be honest, it's not the prettiest API. So also, executors don't support streams of data. You just run something on the background thread, and then somehow you're handling the result. OK, RxJava does support streams of data, and it does have a large amount of operators. But unfortunately, it also comes with quite a steep learning curve. And because out of 4 people, only 1 had experience with RxJava, we thought that this is quite a big downside of Rx. And thirdly, we looked at coroutines. So coroutines have this very nice ease of learning. It's really easy to do the first steps in coroutines. And because a lot of times, if you look at Rx, operators like single or classes like single, maybe, and completable are just used to move something, to trigger something on a background thread. Well, we knew that actually we can just do this by launching a new coroutine by using suspension functions. And also, coroutines support streams of data via channels. So this is something that we haven't looked at so far, but the fact that we knew that this is possible in Kotlin, we decided to go with coroutines. So we knew that also coroutines should be launched as close as possible to the UI. Because, for example, you're opening a new UI, you're triggering some request from the network, but you know that when you're closing that activity, you also want to cancel it. So we knew that the launch and the cancel need to be as close as possible to each other in the same class. And everything else on the other layers should be using just suspension functions. So the class that would allow us to do this would be the view model. Also, in the view model will be the place where we're doing this transition between coroutines and live data. So we can have this observability of live data. But I'll suspend the view model topic for now. So this is overall the architecture that we had in mind when we looked about the layers. We knew that we will have a local data source that talks to the database or share preferences. We would have a remote data source that works with an API service. Both of these two, the local data source and the remote data source, will be used by a repository. In the domain, we would have use cases. And then in the UI, we would work with view models, activities, and XML. So because we wanted to make sure that we're creating a common language in our team. We wanted to make sure that when we're talking about the local data source, we all mean the same thing. We ended up deciding or creating a set of rules for each of these classes. So let's start with the data layer. OK, so the first one is the API service. In the API service, we use the retrofit to coroutines Kotlin coroutine adapters. So this allows us to return if initially we would have a call, this would allow us to replace the call with a deferred class. And even more because, well, our app is still quite big, and we knew that this switch from Kotlin to Java won't be done easily. We also used the deprecated annotation. So step by step, as we were replacing or adding a new API call that was returning deferred, we would keep the previous API if it was still used and annotate it with deprecated. The API service was used by the remote data source. The role of the remote data source is really just to construct the request data and to actually trigger that request from the service. It would depend on the API service and would get as an input the request information, and as an output, a result of type response. So this result looks something like this. So it's a sealed class. So a sealed class allows us to create, to represent restricted data hierarchies. Because in our case, whenever you're getting data from the network, you either get it successfully or you don't, so you have an error. So like this, our values can only have a limited set of possibilities. They can't have any other type. And a lot of times we ended up using the result in these kind of like when statements, where we were handling what should happen when we have a result of success, what should happen in case of error. But we wanted to make sure that our compiler actually tells us something when we're not handling all of the branches. For example, if we're commenting or we're forgetting to do that. So we want the compiler to enforce an error. So in our case, we wanted to make sure that we get this when expression must be exhaustive, and we need to implement the error branch. Well, when it's only exhaustive when it's used as an expression. So we made the when exhaustive. So more precisely, we just created an extension property on the object, and then we're just getting or using the object as a value, the when as a value. So this is actually just a lightweight way to mean that we mean to match all the branches at all times. Getting back to our remote data source. Let's see how it actually looked. So for example, we had a comments remote data source that was working with a designer news service to get the comments for a story. So here, if you want to post a comment, we would have a suspension function that would get the comment body and some other information as parameter. And it would return a result of the comment response, this being the response from the network. In the implementation, we would create the comment request based on the information that we passed as parameters in the function, and then we would trigger that request to the API. And then we would handle the response. If it's successful, we would create our result of success. If it's error, we would return a result of error. But actually, this code is not enough. Because if, for example, your application is offline, your network is disabled, then this code will crash. What you need to do extra is to wrap this into a try-catch. So this means that absolutely every call that we were making was supposed to be wrapped up inside these try-catch statements. So this means that the code ended up being bloated, and then the actual important code, which is creating the request and triggering the request, was somewhere lost in these try-catch and other mechanisms. But Kotlin helps with this with the top-level functions. So more precisely, we created a method that's called a safe API call, where we are passing a suspending lambda. and also an error message. So here, we're just calling that lambda, and then wrapping it inside a try-catch. And then if indeed we get an exception, then we're just creating that result of error based on the error message that we previously passed. So this will be used like this. Our method would just call this safe API call, and then we move the code that we had initially inside its own method. And this looks something like this. So here would be the place where we're creating the request, triggering it, and handling the response. So this means that now the code that actually matters is nicely separated in its own function. Okay, local data source. Its role is just to store data on disk. It would depend on shared preferences or the database, and would get as an input the data that has to be saved, and as an output, the data that was saved. In our case, we only have local data sources for some of the features in the app. And even more for now, we don't have a database. We only work with shared preferences. But we know that because the code is so isolated inside this local data source, we can make that modification in just one class and replace the shared preferences with room, for example. The repository would be the class that works with the local and the remote data source. Its role is to fetch and store data, and optionally, to cache in memory any data that it's needed. As an input would be some IDs of the data that needs to be retrieved, and as an output, the data that was saved, also wrapped inside the result object. So a repository would also expose suspension functions. And ideally, in the architecture that we wanted, the domain layer would be the one that calls this suspension function. But again, we were moving from an app that was written in Java to Kotlin. So while we were refactoring, our code actually looked something like this. We had features where we had already moved to the domain layer. We had features where our app was, or the repositories were still called from a UI that was in Kotlin, but we still had quite a lot of chunk of data or of classes that were still in Java in some non-architected way. So we knew that our repository needs to support being used from all of these options. So, for example, when we implemented the shots repository, where we're able to search based on a query, here we would have a suspension function that returns a result of a list of shots. But if you're trying to call this method from Java, you would need to implement something like this. You would need to implement a continuation, decide what happens with the context, decide what happens when the result is successful or with error. So this is not really nice, because where do I get that context? Who is that context? How do I cancel all of these? So we ended up, looking at other options. So we looked at how the code we had initially looked like. So we had a map of a string and the call, the retrofit calls that we were doing initially. And we saw that in our repositories, we also make sure that we're canceling those calls. So we decided that, at least for now, to just keep the same mechanism, to combine the callbacks with the coroutines. So we just replaced the call with the job, and when we're canceling all the searches, we're also canceling our coroutine jobs. And then inside the search, we would launch the coroutine, and we would return the result via that onResult lambda. So this means that we ended up making a compromise. But it felt like it's good enough, or it's good enough for the beginning, until we actually managed to make all of our classes in Kotlin. And we saw that for the features where we indeed were able to do this, going from callbacks to suspend functions to our desired pattern was actually quite easy. Okay, we had another problem. So when you're adding a comment to a designer new story, you can either add a comment to the story or to a comment. So these under the hood are only actually different based on the story or based on the ID that you're passing. You're either passing a story ID or a parent ID. But if you're looking at these two methods, they're actually very similar. They all get string, long, and return a result of a comment response. So what we actually wanted is to be able to pass a story ID to keep the same comment, but enforce that type safety between a story ID and a comment ID to make sure that we're not passing by mistake the ID of a comment, instead the ID of a story. So we recently moved to Kotlin 1.3, and there's a feature in Kotlin 1.3 that can help us with this. So one way of handling this, independent of the Kotlin version, would be to wrap the ID inside the data class. And then in our data class for story, we would just use that wrapper. But the problem here is that you're creating a new object just to wrap along. So in Kotlin 1.3, we also have inline classes that avoid this kind of extra object creation. But although we moved to Kotlin 1.3, we decided not to use inline classes for now, because functions with inline classes can't be used from Java. So it's one of these features that we really like. It's really saving some more memory for us. But we will wait until our classes are more moved to, or our dependencies are more moved to Kotlin before we start using it. OK. In the domain layer, we had use cases. So the role of the use case is to process data based on business logic. It would depend on repository and of other use cases. It would get as an input IDs, and as an output a result of type T. And what's extremely important is that the use cases should have a single task responsibility. And you'll say, OK, but shouldn't all classes have this? But yes, but these use cases should really be light and reusable. And we wanted to find a way to enforce this single task responsibility. So for example, we would have a post-comment use case that would get the comments repository and the login repository. But when we want to post a comment, we would only get the body of the comment and the story to which it's added. But then it would be the responsibility of the use case to know that it also needs the user ID to post this information. So this means that whoever calls this use case doesn't need to know about the login repository also. So because our post-story comment use case should only do one thing, to post a story comment, we decided to use the invoke operator. So more precisely, the objects with the invoke method can be invoked as a function. So this means that when we are using our class, we can just call post-story comment use case of the comment and the story ID. Even more, as a convention in our team, we decided to completely drop the use case. And then what we're left is with something that actually looks like a function. But because we also made the convention that in our class, in our use cases, only the invoke method is a public method, then everything is nicely abstracted. So even if it looks like a function, we have everything separated in its own class, in its own testable class. OK, let me tell you about another problem that we had. So I was saying that for the designer news, we have these kind of threaded comments. So for example, here we have several main comments to the story, and then we have replies to those comments. But the thing is, the API that we were working with, when we were requesting the information for a story, it would only give us the IDs of the parent of the comments. So in this case, it would only give the IDs of the comments that are emphasized. So then we would need to request those comments, and there we would get the IDs of the replies to that comments. And then again, we would need to request the next set of comments to get the IDs of those replies, and so on. What we were left with was with a list of lists of comments that afterwards needed to be matched based on the parent ID to which they belong to. OK, so to do this, it meant that we had to work a lot with collections. So more precisely, we work with methods like group by or map. So these are extension functions on the collection that allows us to make all of these kind of operations easier. But things weren't stopping here with our comments. So for every comment, we had the ID of the user that added that comment. And of course, in the app, we couldn't just show the user ID. We wanted to show the name of the user. So this meant that we had to create a set of all of those IDs of the users, then request that user information, and then map all of that user information back to our comments. So it took so long to explain all of that, when actually the code is quite simple. So here, in the case of the user, we work with sequences. So sequences are lazily evaluated collections. So the thing is that when you're using collections, for every operation that you perform, a new collection is created. But with sequences, the operations are performed on every element, and then the collection is only created at the end, so at the place where toList is being called, like this. Because we're skipping over that extra collections being created at every time, we improve the performance of our application. So overall, Kotlin has in its standard library a lot of extension functions for both iterable and sequence. So in general, whenever you have anything to do with collections, before you start implementing your own mapping like I did initially, check out what's available, and you'll find out that you'll be able to skip a lot of the boilerplate that otherwise you'll have to write. OK, so we looked at the data and the domain layers. Let's see what's going on with the UI layer. So here we had a view models, we have activities and XMLs. And I also added XMLs here because we're also using data binding. So let's see the roles of every class. So the role of the view model is to expose data that's displayed by the UI. It would also trigger actions on use cases based on the user's actions. And even more would be the place where we're launching and we're canceling coroutines. The view model would depend on use cases and would get as an input, if it's a detail screen, for example, IDs. And would also get as an input the user's actions. And then as an output, it would have a live data of a UI model. Let's see how the implementation would look. So for example, for the UI where we want to display a detail screen for a story, our view model looks something like this. So we would have as a parameter the story ID, the ID of the design on your story, and then several other use cases. And we would extend from the view model. But we would also create a view model factory. And this is because, by default, the view model constructor can't have arguments. So so we will have a view model factory for every view model that we need to create. And this is also something we did because we wanted to have the view model immutable. So this meant that we wanted to make sure that that ID doesn't change. So this means that if we have multiple instances of the same activity opened, we want to make sure that we have different instances or a corresponding instance of the view model for each instance of the activity. OK, so in the implementation of the view model, we would expose a live data of a story UI model. So we would also use a mutable live data as a backing property because we wanted to make sure that only the view model is the one that that modifies this live data. And then the live data that's consumed by the activity can't be modified by it. And we're exposing separate live data for events. So for example, if you want to open a URL or if you want to show a notification, we would expose live data of an event. So the thing with the event is that when we're opening a URL, for example, and then we're rotating the device, we want to make sure that we're not opening that URL again just because we're binding again to that live data information. So to do this, we created this wrapper over the information in live data. The only thing that this wrapper has extra is this consumed flag. And this flag is moved to true once we got the data from the live data once. So why we ended up going with this kind of solution and not others is explained really well by one of my colleagues, by Jose Alceraca, in his blog posts. Here, he looks over different problems that you can have with live data and different solutions together with advantages and disadvantages of it. And the best case or best solution that he could find was to use events. OK, so I said that we have activities and XMLs, but actually both of these use the view model. And here's how. So in our activity, we would use a late init view model. And then only in onCreate, we would initialize that view model. And then in the XML, we would declare the view model as a variable part of the data block. And we would directly bind to the data inside the live data in our text views, for example. So here, our view model UI state is that live data that holds the state of the UI. So here, instead of doing this mapping and observing inside the activity, we're directly in the XML telling that we're interested in the title from the UI state. So looking at the UI, for now we have just the view model, the activity, and the XML. And to be honest, I think this is the part of the application where there's most room for improvement from the architecture point of view. So Plaid is such a UI-heavy application that we're still trying to figure out what's the best way to handle things. For now, it felt like this is good enough, but we know that we can do even better. We thought of maybe introducing a presenter at one point, but we'll still want to figure out, okay, what would be the role, what would be the life cycle of all of these? Okay, so we looked at the data, domain, and the UI layer. But there's one thing that I didn't mention. How do we test this? So in general, well, when we started working with Plaid, it had 0 tests. So every time we were refactoring and we were creating a new class, then we made sure that we're unit testing that class. And then things that work, for example, with the shared preferences, would also be tested via instrumented tests. And then everything that's related to the UI would again be tested with instrumented tests. But more precisely, we actually used unit tests as a way of verifying that the architecture is correct. So we looked at different layers, but I didn't say anything about how we've refactored or if we refactored things in modules. So initially, we had everything inside the app application. So with the app bundles and with the dynamic delivery, the app module is actually the one that gets installed when a user downloads Plaid for the first time. So we started splitting things. So we created a core Android library where we moved everything that's not actually related to the home activity. And then in the app, we only left that home activity where we're gathering all of those all of the feeds from different data sources. Okay, so, and then once we had everything in core, we started breaking things apart even more. So we created dynamic features for designer news and Dribble. And here, designer news and Dribble depend on the app. Then we split things even more. We added search. So the search functionality is in its own dynamic feature. The about, it's in its own dynamic feature module. So even if they are dynamic features, because we didn't enable the dynamic delivery for now, they come bundled in the app when you're installing the application. But the thing is that we have this strict modular separation between dependencies. So it means that this kind of architecture already forces us to ensure that we are not leaking classes between one module to another. And I think there are a lot of things to be said about our path to modularization. But one of my colleagues, Ben Weiss, published yesterday actually a blog post on this, and I didn't manage to look to add it, but Google for Plaid and modularization, and you'll find it. Okay, to button up. So I said that initially before we started the refactoring, we looked at our goals, we defined our goals. We knew that we wanted to fix the broken functionality. Well, right now, from a product perspective, I think we're getting quite close to the goal. Most of it is quite fixed. We were able to add most of the functionality that Plaid initially had back to life. We only have still a few buttons to sew in here and there. But then from the code perspective, I think we still have quite a lot to go to actually reach our goal. But we could see how Kotlin features like seal classes and Invoke operators and extension and top-level functions and others, together with the architecture components, helped us build this modular, extensible architecture that we are striving towards. And then we also saw how other Kotlin features, like the extension functions on collections, are those features that make our daily life as developers more pleasant, more delightful. So join our beta testers group to help us find out what other issues we created while we refactored, and keep an eye on our GitHub project, because we are actively working on it. We're continuing to work on it. Thank you on behalf of the Plaid team.